Bismillahirrahmanirrahim. Now I am going to show how to design raft or mat foundation in Prota structure. In this tutorial, I'll show some important tips and tricks in Prota structure, because in YouTube I did not find any tutorial about these things. So now, to learn these things, you have to be careful from the beginning to the end of this tutorial. So let's start. For raft or mat footing foundation area, we have to draw slab. There are a lot of options. Here the level, slab level at center or corner, this is leveling. This is not a big issue for leveling. Here is the thickness, and here is the type. These types are used for different types of slab in floors. And for mat foundation, when we will draw, like in this one, axis region, beam region, peak axis, peak point, there are 4 options for drawing the region. So axis region like this, here like this. Will not do that. I'll show another type. For another type, here beam region, here same. If you draw any line by this, or if you draw any area by this, then you can select that one to get full area. Peak axis, this, 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 and this. In this way we can draw a slab for the full area. By picking point, we can draw the slab region. For this projection, here is the type, cantilever type. If we select this one, here we can write the projection. Then we can draw like this one, here to here. This is the projection coming. But for curved edge, this will not work. That's why we will not do this in this way. So close this one, go back. Now I am going to show how to draw the raft area or mat foundation area offset from this axis 2 meter offset from this outside axis. So first of all, we will draw axis. Right click on this offset axis, in this way direction, press F2, 2000. Okay, now this one offset this way, press to F2, then enter the value 2000, that means 2 meter, enter. Press SC, then offset axis this way, press F2, 2000, 2 meter. Sorry, this needs negative value. Offset, press F2, minus 2000, enter. Okay, now this one offset, press F2, 2000, enter. Now try this, press F2, minus 2000, enter. Okay, for this one offset, press F2 2000, enter, then determine the direction which way you want to. In this way I want to make offset. Right click, then click on the mouse, left click, this will be done. For this one, offset, press F2 2000, enter, done. Now this one I will stress, add to here, right click, stress from this point, this one I will stress same way, right click, stress axis, it is going there, right click, stress axis, now it is going here. Okay, we can offset this one for more. Press F2 1000. Okay, now this one I will delete. So here we have got some axis. In this area we will draw the mat. Go to slab, I will take thickness 400 millimeter, then insertion, axis region, this one I will start from this, sorry, not this one, go to again here, write 400, then clear cover 50, insertion, pick axis, this one, then this, and this. Okay, done. So this is the mat area we have drawn for design. Now we will go to the 3D view. Okay, this is the 3D view of the structure. Here we will run the analysis, building analysis. Here is the analysis option. In model option there is share all model. This is selected as peer mid peer model, and here another option for meshing 500 and 500 millimeter shell size. So in this case I am showing the scenario analysis, start, okay, this is done. Now we will go to post analysis option, analysis result. We will click on this. Here you see the shear wall is acting like a column with one node, single node. So we will do one thing, we will close this one, we will select the shear wall option, finite elements shell model. This is 500 by 500, I am keeping same like this. Okay, analyze. We will run analysis again. Building analysis, then start. So analysis done. Okay, we'll go post analysis. Model and analysis result display. Now see, the share all has been meshed into 500 by 500 shell size. You can see the share all stress M11, F22, M22, M12, F12. So after doing this analysis, we will go to Raft foundation, close this one. Now I will go to plan here. Now go to the option finite element Raft foundation analysis. Here also you will get finite element Raft FE Raft foundation analysis. So click on this. Here are the some option. Include column section in FE model. This has to be included in the Raft foundation for shear checking, punching shear check. Okay, and here are the allowable stress of soil 200 kilonewton per square meter. Now we will run the foundation mesh and analysis. Click on this. Here uniformity factor you can increase or decrease, and plate element size, if we increase this one then plate element size will be bigger, and if we decrease this size then it will be more small and it will be more accurate. So I'm going to increase 1000, then generate model. Okay, so this is the size. Here the column section, column it is having the edge area, all the edges. So meshing is very nice in Prota. You can increase this one, then size is getting bigger. I will make it 1000. Okay, now I will go to post processing. This is coming. This needs little bit time to calculate the member result. Okay, done. Now this is done. The green tick. Click on analysis post processing. Here are the load values in each nodes. All the column support. It is showing the reactions in all direction. Vertical, horizontal, all the reaction is acting here. So for mat, the reactions are acting in this direction to the mat. For shear all, according to the meshing, the reactions has been distributed in the distributed nodes. Here we can see the displacement. Stop. You can see the standard contours. This. Here we can increase the scale. Stop. Now we will go to plan view, result. Here are the user defined contours. In this option we can provide reinforcement according to the required reinforcement. Here the contours will be shown according to the parameters. Go to this one. Okay, display shaded contours, this one, and display line contours, both we want to see. Now here you can see the bending moments, mx, my, mxy, bending moments 3, m2, m12, design moment, md bottom, md2, y direction bottom, md1, y direction, this x direction, and required steel area. Here we can see this. Here are the bottom reinforcement requirement: millimeter square per meter, maximum 1368 millimeter square per meter. We will edit contour. Go to edit. Okay, this is bottom in one direction, this is maximum. So here number of contours 8. We can change the number of contours so that, yes, here is the 0 to maximum. All the value will be divided by 6. There will be interval, 6 interval, equal interval. If it is 8, then there will be 8 number interpolation number of the contours. Okay, now we will provide the reinforcement and we will check. This is the required, we will check, and this is the maximum. We can provide above the maximum 16 millimeter dia, 100 millimeter spacing. This is coming 2011, that means more than maximum. We will provide 150, 1340, little bit less, 40. Okay, this is more than maximum. So now this update. Here we can put contour label, update A16 140 spacing. I am keeping value, update. Okay, done. So this contour we will export. Okay, this one also, edit contour, steel bar 16 125 120 100 110 millimeter. Okay, update. Okay, export this contour. Then desktop, edit contour, steel bar 10 150. Okay, update, done, export the counter. Okay, and this one, edit counter, still bar 10 150, update. Okay, export counter, done. This is our provided reinforcement. According, we have decided according to the required reinforcement, and these counters we have exported to our model. Now we'll close this one, and this will show, export the result, transfer slab strip analysis. Okay, okay, okay. Now we can see here the counters, FE counter. See, this is the top, bottom direction 2, top direction 1, top direction 2. This is requirement in the middle strip of the span, and bottom at the bottom of the column strips. Okay, now we want to design the reinforcement. For this we have to draw contour line, slab strip line. We will go here. First we will display this none. Okay, okay. Now we will draw strip line. For this, first we will go to X direction, and this will be finite element strip properties. We will select this one, finite elements strip, this start, this end, and here we will select this one, integral strip, for economic design. Now we will draw from, for column strip, here to here, here to here, here to here, here to here. We can adjust the strip widths by this, by adding the length left right, or and also with this cursor. Select this one, then now we have drawn the strip. Now we can adjust this one by providing the left right length or by the cursor. So first we will select the strip, shift this one, select. Now click on this. Here we will click on this cursor, then here click update this, and here you can first, we have to click on this, then click on that point, then update. Okay, now press ESC, select this strip, go to strip option, properties, click on this, we will select this point, update.
Press the bell icon on the YouTube app and never miss another update.